Today in Math 3, we're going to be looking at determining domain restrictions. This is similar to what we were doing in our last topic when we were finding the vertical asymptotes of our graphing rational functions, and that we cannot have 0 be a denominator of our fractions because it causes vertical asymptotes, because it's not allowed. Okay? So when we're doing these types of problems, what we're going to be doing is finding the values of x that would make your denominator 0, and those are the values that can't be used as answers to your equation. Okay, so these are what's called domain restrictions. All right. So how to do this? You're going to take your denominators. In this case, we only have x plus 3, set it equal to 0, and solve for x. So if we subtract 3 from both sides, we get x equals negative 3. But here's where it's different. The only thing that x cannot equal is negative 3. So this is your domain restriction. So we figure out what x equals. Whatever that is, that's what it can't be. Okay, for your domain. All right, let's look at the next one. In part B, okay, we have 2. This has already been factored for us, so we have 2 parts. We have x plus 8. We're going to set that equal to 0, and x minus 2. Set that equal to 0. So x will equal negative 8, and x will equal positive 2. But these are the values that x cannot be. So if we solve our equation and find out that x is going to be equal to negative 8 or positive 2, those values, because they would cause the denominator of your fraction to be 0, can't be used. Okay. All right. Next problem. Now we have a denominator where it's a quadratic expression. So we have x squared minus 5x minus 14. What we're going to do is we're going to factor this. All right. So two numbers that multiply to give you negative 14 and add up to give you negative 5 would be negative 7 and positive 2. Now that it's factored, we can take each factor, x minus 7, set it equal to 0, x plus 2, set it equal to 0, and solve for x. So x equals 7, and x equals negative 2. These are the values that x cannot equal. These are your domain restrictions. All right. Moving on for D. All right, so we have 2x cubed plus 16x squared plus 30x. So in this case, you have a much bigger equation to factor. It's got a lot more stuff going on. What we do see in this problem is that we can take out both a 2 and an x as a greatest common factor. We'll be left with x squared plus 8x plus 15. We can then factor what's inside the parentheses. You need to find two numbers that multiply to be 15 and add up to be 8. Those numbers would be positive 5 and positive 3. Now, one thing that you have to make sure you do remember is that that 2x that's out in front has to stay there. It is part of your factorization, and it is going to be part of your answer. So you have 2x equals 0 because it's part of the factors, x plus 5 equals 0, and x plus 3 equals 0. If you solve all these for x, you're going to get x equals 0 because you divided by 2. 0 divided by 2 is 0. X equals negative 5, and x equals negative 3. So these are what all x cannot equal when you're done. Two more. Very simply, x minus 6 equals 0. X cannot equal positive 6. That's pretty simple. And lastly, x squared minus 5x. Now this one always gets students tricked because they're looking for that third term to factor like we did in the one right above it, where we had x squared plus 8x plus 15, the trinomial. This is just a binomial, and you can't factor it the same way. What you can do, though, is take out a greatest common factor. You can take out an x, off with x minus 5, and that's all you can factor. Now you take both your factors and set them equal to 0, and then solve for x. So the first one's already done for you. It is equals 0. So x cannot equal 0. And then the other one's going to be x equals 5, and x cannot equal 5. That is your domain restrictions. So again, you're looking for what answers the denominator, or what values for x you would get, and then those are the values you cannot use to solutions to your equations, because they would cause your denominator to be 0. And those are domain restrictions. Good luck.